I will introduce Andrew, also known as Pandy, or the automation panda. Everybody needs a hook. He is a software testing and automation champion who loves to help people build better quality software. Currently, Pandy is a developer advocate at Applitools, which is a great company, where he helps folks do the best visual testing they can, and also the focus of today's presentation, what does that mean, visual testing? He also leads Test Automation University, which offers a multitude of free courses on software testing. And if that weren't enough, he is also writing a book on software testing, and we look forward to reading it. Wow. So, Andrew, just one thing, everybody, can you write your questions in the chat or the Q&A, and Andrew will address them at the end. There we go.
Cool. So, hello, everyone. I shall share my screen. Bam, how we all doing this morning or this afternoon, wherever we might be in the world. Thank you, PractiTest, for inviting me. I'm glad to be here. As Mayan said, my name is Andrew Knight. You can call me Pandy for short. I am the automation panda. Historically, I've been a software engineer in tests, building high-scale solutions to testing problems. But for almost a year now, it's coming up, I have been the developer advocate at Applitools. Another cool thing I do at Applitools, I run Test Automation University. I'm now the director of TAU. It's one of the best platforms for online learning about testing, automation, software quality. We've got over 70 courses on a bunch of topics, adding more every month. And I even taught a few on Python myself. So go check that out. It's awesome. Today, I'm going to be talking about testing. Surprise! Who would have thought? Wow. But in particular, though, I'll be talking about visual testing. Visual testing techniques are an incredible way to maximize the value of your functional tests. Instead of coding a bunch of assertions based on text or attributes, visual testing captures a full snapshot of a page and looks for visual differences over time. So my goal today is to open your eyes to see how visual testing can revolutionize how you approach software quality. This isn't just another nice to have feature that's on the bleeding edge of technology. It's a tried and true technique that anyone can use, and it makes testing easier. So I want you to see things in new ways. And we'll also show how to do visual testing with PractiTest, because PractiTest as a test management tool can manage any kinds of tests, including functional tests with visual assertions. So I'm sure we all know there are several kinds of testing. What kinds of testing have y'all done? I mean, drop them in the chat. We'll look at it afterwards. But here is a splattering of buzzword bingo, right? There's unit tests, mobile tests, integration, end-to-end, performance, web UI, REST API, behavior-driven, data-driven, whatever else you want to be driven by. I'm driven by Volkswagen, so that's just me. But what is testing, if we were to define it? In simplest terms, testing is interaction plus verification. That's it. You do something, and you make sure it works. Every kind of testing reduces to this formula. Manual testing accomplishes both interactions and verifications by direct human interaction. Somebody needs to bang on a keyboard to drive the test. Automation, on the other hand, drives interactions and verifications with a script. We like to think of automation as so great because it doesn't need any human intervention, but we all know that's not really true. Humans still need to write the tests and develop the scripts and fix them when they break. Paradoxically, test automation isn't fully autonomous, much to our chagrin. But visual testing helps to change that. Although humans still need to figure out interactions, visual testing techniques make verifications autonomous. Teams take snapshots of their views and look for changes over time. They catch more kinds of problems while ironically simplifying their test code. A tester doesn't need to think as critically about what specific elements to check on the page because snapshots capture everything. Unfortunately, many folks seem to have the impression that visual testing is an advanced technique that requires a high level of testing maturity to be valuable. That's not the case at all. In fact, I want to flip that script entirely. Visual test automation is easier than traditional test automation. It isn't some bleeding edge technology useful only to FANG companies. It isn't out of reach for teams just starting their test automation journey. Visual testing makes functional testing easier and stronger. It's something teams should do first before attempting to automate longer, more complicated tests with traditional techniques. Big claims, right? Let's see what I mean. Today, we're going to automate a web test together in Java with Selenium WebDriver using traditional interactions and verifications. And then we'll supercharge it with visual testing techniques using Applitools. And we'll be showing how that can integrate with PractiTest for reporting. So first, we need a web app to test. We could test an app of any size, but I'm going to choose a small one for the sake of our demo. This is Applitools' demo site. It mimics a banking application. You can try it yourself at demo.applitools.com. The login page has a main icon, username and password fields, and a sign-in button. Since this is a demo site, you can enter any username and password to log in. You don't even need to enter any, you can just click the button, but we'll just enter it in just to pretend. So after clicking the sign-in button, the main page will load. Now there's a lot of stuff on this main page. The top bar has the name of the app, has a search field, icons for your account. The main part of the page shows financial data. There's a left sidebar showing different account types. We could write a basic login test for this application in 4 steps. Load the login page, verify the login page loads correctly, log into the app, and verify the main page loads correctly. This could be like a smoke test. There's nothing fancy here. And really the trickiest part for automation would be deciding which elements to check on the loaded pages. So if we automate this test in Java using Selenium WebDriver, it could look like this. I mean, technically, we could automate this using any popular tool or language. Personally, right now, I really like Python and Playwright. But based on different reports I've seen, Java is still one of the most popular languages. For automation, Selenium WebDriver remains the most popular tool. So we're just going to use that for the sake of this example. JavaScript, C#, Ruby, all other popular languages for automation that are good, including Python. Cypress, also very popular alternative to Selenium as well as Playwright. So in Java, we have our JUnit test class. We've named it login test. We've created a test case method named login, and it makes calls to 4 helper methods, 1 for each step. Just good structure. First method, load login page, would load the demo apps login page in the browser with the driver.get. Second method, verify login page, verifies the appearance of 5 critical elements on the page: logo, username field, password field, sign-in button, and remember me checkbox. It waits for each of these elements to appear using a helper method named wait for appearance, because we all know waiting or synchronization, whatever you want to call it, is a major pain in the boot when it comes to Selenium. True story, we've all been there. Third method, perform login, enters a username and password, and then clicks the sign-in button. So far, so good. Nothing too bad, right? Hold on to your boops. Fourth method, verify main page, is quite a doozy. Remember all the little things on that main page? Well, they'll need several assertions to verify. Some assertions merely check the appearance of the elements, but others need to perform text matching. For example, to check the banner at the top that says your nearest branch closes in X number of minutes, we need to find the element, get its text, and then perform a regular expression match. Checking the account types and status fields require getting lists of elements, mapping their text values, and transforming the result data for comparisons. Doable, but a little more painful. And despite this heavy lifting, the page still doesn't check everything on the main page. Dates, amounts, descriptions are all ignored as a risk-based trade-off. We could add more assertions, but then they would lengthen the methods even more. They could also be difficult to write and become brittle over time. Tests practically can't cover everything. If we run this login test against our web app, it should pass without a problem. Ta-da! Yay! But what if the page changes? Here's a different version of the same page with some slight visual differences. Can you see what they are? Let me go back and forth a few times. So, will our login test still work? Will it pass or will it fail? Should it pass or fail? Looking at these two pages side by side makes comparison easier. The logos are different and the sign-in buttons are different. While I'd probably ask the developers about the sign-in button change, I'd categorically consider that the logo change is a bug. Unfortunately, as long as the page structure doesn't change, our login test will still pass. It wouldn't detect these changes. We probably wouldn't have found out about these changes if we relied exclusively on traditional test automation. The step to verify that the login page loaded correctly only checks for the appearance of 5 elements by their locators. These assertions will pass as long as these locators find elements somewhere on the page, regardless of where they appear or what they look like. Technically, even this login page would still pass the test, even though we can clearly see it's broken. Traditional functional testing hinges on the most basic functionality of web pages. If it clicks, it works. It completely misses visuals. Those are huge test gaps. Adding more assertions probably wouldn't catch this kind of problem either. So what if we could visually inspect this page? That would easily catch any changes on the page. We could take a baseline snapshot that we consider good, and every time we run our tests, we take a new checkpoint snapshot. Then we can compare the two side by side to detect any changes. This is what we call visual testing. If a picture is worth 1,000 words, then a snapshot is worth 1,000 assertions. Automated visual testing is what Applitools does. Yay! One visual snapshot captures everything on the page. As a tester, you don't need to explicitly state what to check. A snapshot implicitly covers layout, color, size, shape, and styling. That's a huge advantage over traditional functional test automation. To be honest, testers have been doing visual testing since computers first had screens. Anyone can manually bang on a keyboard and look at the screen to see what changes. That's arguably the first kind of testing that anyone does. It's super valuable to take a quick glance at a page to see what's wrong. Humans can intuitively judge if a page is good or bad in a few seconds. Unfortunately, though, human reviews don't scale well. Modern apps have several screens worth checking, and continuous integration systems deploy changes multiple times a day. Humans make mistakes. They get tired. They miss things. They also have limited time. This reminds me of the legend of John Henry, a folk hero from the United States. I don't know if anybody's heard about John Henry before. Drop in the chat if you have. Be curious to see who's heard this legend. As the legend goes, John Henry was a railroad worker on the Great Bend Tunnel along the C&O Railway in the state of West Virginia. This was back in the late 1800s. When the railroad company bought a steam drill, he competed against it head to head with a 10-pound hammer in each hand. Boom, 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 boom. According to the legend, he drilled deeper than the steam engine could. So technically, he won the contest. But he died from exhaustion afterwards. The legend of John Henry serves as a parable that even the strongest, sharpest human is inevitably no match for a machine. To be relevant in a modern software shop, visual testing must be automated. But that's easier said than done. Programming a tool to capture snapshots and perform pixel-to-pixel comparisons isn't too difficult, but determining if those changes matter is. A good visual testing tool should ignore changes that don't matter, like small padding differences, and focus on changes that do matter. Otherwise, human testers will need to review every single result, nullifying any benefit of automated visual testing. Take a look at these two pictures. They show a cute little underwater scene, probably from like a kid's book or something. There are a certain number of differences between these two pictures. Can you count how many differences there are? I'll give you a few seconds. If you have a count of the number of differences, drop them in the chat. Oh, I see some people going. Let's see what folks are saying. Diana says 5. Linda says 5. Anybody find 6 or 7? Oh, Hannah says 7. Okay. Give a countdown. 5, 4, 3, 2, 1. All right, so let's see how many differences there actually were. Uh-oh. What happened here? Unfortunately, this comparison did a pixel-to-pixel comparison, not a smarter one. I ran these 2 pictures through Applitools using an exact pixel-to-pixel comparison, and this is what happened. Except for the white space on the sides, every pixel was different. As humans, we can clearly see that these images are very similar, and we were even counting some of the differences. But because they were a few pixels off on the sides, the automation failed to pinpoint meaningful differences. Oh, this is where AI is going to help us. Let's try this again. Oh, that's a much better comparison. Applitools uses Visual AI to detect meaningful changes that humans would see and ignore inconsequential differences that just make noise. Here, I've used Applitools strict comparison, which is kind of the default type of comparison. And it pinpointed all the differences. And in fact, there were a total of 10 differences. So I know we said 5, 7, there were actually 10. Things like the mouth of the octopus, a fish versus a starfish, little bits of grass, different, a fish is missing or not. Pardon me. So looking at it now, can you see, oh my gosh, that was really cool. A visual checkpoint would capture all those differences, pinpoint them like this, and reveal them within a split second. Whereas as a human, it might take you a minute and you might not even find them all. This is the second advantage of good automated visual testing. Visual AI, like what Applitools does, focuses on the meaningful changes to avoid noise. Visual test results shouldn't waste testers' time over small pixel shifts or things humans wouldn't notice. They should highlight what matters, like missing elements, different colors, or skewed layouts. Visual AI is a differentiator for Applitools brand of visual testing. Not all visual testing tools rise above pixel-to-pixel comparisons. So let's update our login test to do visual testing. First, you'll need to create an Applitools account. Anyone can create one for free using the links I'm showing here. You can use your GitHub account or an email to get started, and you don't need to pay anything, no need to put in a credit card. Your account will come with an API key that you'll need to set as an environment variable in your test automation environment. Next, we'll need to add the Applitools SDK to our project. Since we're using Selenium WebDriver with Java, we'll need to add this particular package as a Maven dependency to our project's POM file. Third, we need to set up visual testing objects in a test setup method. We'll still use WebDriver, but we also need a visual grid runner to upload snapshots to Applitools Ultrafast Grid, and we need an eyes object to actually take visual snapshots during execution. We'll have a configuration object that sets things like API key, the test batch, and the browsers we want to test. Here, we're just going to test Chrome, but we could test more. Thankfully, the steps for our login test are the same. But before and after the test steps, we must open and close Applitools Eyes so we can take snapshots during testing. Opening requires the WebDriver reference, an app name, and the test name. Now here, I've actually embedded the open and close in the test method itself because I wanted to show everything on one screen. But as a better practice, and in the example code project I'll show in GitHub later, I've actually separated that out such that opening happens in a before test method and the close happens in an after test method. The interaction methods can remain unchanged because we're still logging in, clicking, and all that. But we need to update the verification methods. We can completely replace our traditional assertions with this one-line snapshot call. Look at it here. 5 lines, reducing to 1 eyes check. And that eyes check is going to cover everything on the page. Much nicer. The impact on that verify main page step is far greater. One visual snapshot eliminates the need for several lines of complicated assertions. That's the third major advantage of visual testing. Visual snapshots greatly simplify assertions. Instead of spending hours deciding what to check, figuring out locators, and writing transformation logic, you can make one concise snapshot call and be done. As an engineer myself, I cannot understate the cognitive load this removes from the automation coding process. I said it before and I'll say it again. If a picture is worth 1,000 words, then a snapshot is worth 1,000 assertions. So what about cross-browser and cross-device testing? It's great if my app works on my machine, but it also needs to work on everyone else's machine. The major browsers these days are Chrome, Edge, Firefox, and Safari. The two main mobile platforms are iOS and Android, and they manifest on countless numbers of device platforms. This might not sound like too much a hassle at first, but let's consider all the versions of each browser. Typically, you want to verify your app works on the latest 2 or 3. All the screen sizes. Modern web apps have responsive designs that change based on viewport. And all the device types. Laptops, desktops, they all have various operating systems. Phones and tablets come in a plethora of models and screen sizes and orientations. And oh my goodness. We have a combinatorial explosion. Traditional functional tests must be run start to finish in their entirety on these platforms. You really have to kind of pick and choose and then take measured risk there. Most teams will pick a few of the most popular combinations and skip the rest. But even just a few choices could still require lots of test execution. Visual testing simplifies things here too. We already know that visual testing captures snapshots of pages in our application to look for differences over time. But notice how I use the word snapshot and not screenshot. That was deliberate. A screenshot is merely a rasterized capture of pixels reflecting an instantaneous view. It's frozen in time and in size. A snapshot, however, captures everything that makes up the page. The HTML structure, the CSS styling, and the JavaScript code that brings it to life. Snapshots are more powerful than screenshots because snapshots can be re-rendered. For example, I can run my test one time on my local machine using Google Chrome, and I could re-render any snapshots I capture from that test on Firefox, Safari, or Edge, getting my cross-browser coverage. I wouldn't need to run the test from start to finish 3 more times. I just need to re-render the snapshots in the new browsers and run the Visual AI checker. I could re-render them using different versions and screen sizes too, because I have the full page, not just a flat screenshot. This works for web apps as well as mobile apps. Visually based cross-platform testing is lightning fast. A typical UI test can take about a minute to run. It could be more or less, but from my experience, 1 minute is a rough industry average. It's what we call the rule of ones. Milliseconds for unit tests, seconds for API tests, minutes for web UI tests. A visual checkpoint backed by Visual AI takes only a few seconds or even a split second to complete. Do the math. If you have a large test suite with hundreds or even thousands of tests that you need to test across multiple configurations, then visual testing could save you hours, if not days, of test execution time per cycle. Plus, if you use a service like Applitools Ultrafast Test Cloud, then you won't need to set up all those different configurations yourself. You'll spend less time and money on your full test efforts. I made a lot of bold claims about visual testing, so let's see it in action. I'm going to switch over to a demo here. Okay. So here I have a Java project. It's the example project for the code I've been showing. At the end of this presentation, I'll share that link out on GitHub. And we have a visual test case. It's just a JUnit test. It's got all that visual testing objects that we talked about. When we're setting up to run, we've got, setting up the visual grid. We're going to run 5 visual checkpoints in parallel. And I'm doing things like setting up my API key. That's tied with my account. So when I upload to Applitools, it knows where my stuff is. Setting the batch name, calling it a visual testing revolution. And then here, I'm going to be testing 5 desktop browsers of various viewport sizes and types, Chrome, Firefox, IE, what have you. And then testing mobile devices as well, iOS as well as Android, Portrait as well as landscape. Setting up the test, we create our Chrome driver, we set up our Applitools eyes, we open the eyes. We saw those 4 test steps before, no big deal. Cleaning up, quit the driver, close the eyes. And you can see I'm making my visual checks. The code for the actual test case here is pretty concise, which is really nice. I also have it hinged to target either the original version of our demo site or that tweaked version. And we'll see, does it detect the failures? Now, the interesting spin on this here is not only do we have the Applitools stuff, but when we run this, it'll also upload test results to PractiTest. PractiTest being that awesome test case management system. It's really nice because you can make API calls as your tests are running to upload results, and you can see them in real time. So to do that with Java JUnit, I created this PractiTest result publisher class. It's kind of like an aspect. It's going to extend our visual test with this. And if we look at that class, all it's doing in here, it implements the test watcher interface so that at the end of the test, when there are results, it'll handle them appropriately. So what I've done is I have a mapping of every single one of my JUnit tests, which in this case, I only have one, to the ID of that in PractiTest. And I'll show you the PractiTest stuff in a moment. Then what I do is I read in my email and my token from PractiTest. And then I formulate my request as basically just a post to this particular endpoint here. And I make it a post, I give my basic HTTP authentication, and then in the data of it, I'm saying, hey, here's the instance of the test that ran, and here's the exit code, pass or fail. And then it pushes it. And so then depending on the type of test result, disabled, success, aborted, failed, it will publish that result from my particular test with the appropriate result. Pretty cool. So if I were to run this test, let's do that now. The first time I run the test, it will establish the baselines. So we'll see there should be like new results in Applitools, and the test should pass the PractiTest. I'm going to run it from my local machine. The test will run locally once on Chrome. It'll upload visual snapshots to Applitools Ultrafast Grid, run the 10 browsers up there, then report back to the test saying pass or fail, and then push that to PractiTest. So here we have it running. We'll let that do its thing. I will switch over to the Applitools Eyes dashboard, and we can see it's uploaded one test run, has fanned out into multiple renderings in Ultrafast Grid. And each one of these, here we go, is capturing a visual snapshot. So here, this one, it captured it on Chrome desktop. We can see it captured 2 images, the login page and the main page. We can look at it. There's no comparison happening because it is the first one. It's a baseline, but you can see this will be our starting point. This looks good. This also looks good. If I refresh again, I mean, it takes a few seconds here. I could do a different one, and we can see it was a different rendering from the previous one because it was different browser, different viewport size, all that. And so here, that responsive design is covered. So now they should all be passed. Yep. So the test passed, and the status is new because it established new baselines. If I then hop over to PractiTest, I can see it from my full testing dashboard. I've created a test set called Automated Visual Test with Applitools there is one test in there, log into Acme Bank. That was the name of my test. I had to come in here and manually set these things up. I believe with PractiTest, you could have it push API calls from your test suite to create these things on the fly if you wanted. Double check me on that. I've only just started learning PractiTest, but I went in, I set these up manually, but then let's refresh now that the test is run. And we can see, it got that passing result. So, and I didn't have to upload the passing. I didn't have to come in and say it passed. That was because the test ran and did that post, the HTTP post with the result. You can drill into the individual test instance here, and we can see July 13th of July at 10:33 in the morning. That's my time locally. I'm 10:30 a.m. I don't know where all y'all are in the world. But yes, boom, it was an automated test. The result passed. It was an API push. So cool. If we're to run this again, then what should happen is, since we have the baseline image established, then now it should be doing the comparison. So I'll run this test one more time. Boom, boom. Oh. So again, it runs one time locally to capture the snapshots. And that's what we're seeing here in the Chrome window. Boom, boom, does the test, boom, boom, very quick. And now it's uploading those snapshots to the Applitools dashboard. So we can flip back and we should see, yep. So here is the next test batch in the Applitools Eyes dashboard. And give that a few seconds. Boom, boom, boom. Already we're seeing some passing results. So here it's not new anymore, it's passed. Because if we look at these snapshots, it's now comparing baseline to that current checkpoint, and it's not detecting any meaningful visual differences. So it's saying, aha, we're good, pass the test. Boom, boom, and if we refresh, it's, yep, almost done now. Give it just a few more seconds. Come on, man. Yep, all done. So it took only 42 seconds to do all 10 of those cross-browser tests and cross-device tests, which if you've done anything with other more traditional platforms or your own Selenium grid, you know that's really, really fast, because that many tests could take like 5 to 10 minutes, you know. So, all right. Then back over to PractiTest. Here's my test instance, and when I refresh, it should have a new result. Boom, and there we go. So now at 10:36, it has the second result. So it's always updating that existing instance. So yeah, that's pretty cool. Now, let's run one more test, but this time let's introduce the visual difference, the change, right? That broken icon link. So I'm going to say run visual test for the changed one. I should also caveat, I'm using IntelliJ here. In my run configurations, I'm explicitly setting the values for my environment variables. So like my Applitools key, my PractiTest email, my PractiTest token, all that is in there. I'm not going to show you because I don't want to show you my private stuff, but just note that it is being set in the environment so I can run these tests. You could set that in a CI system, whatever. You don't have to run it locally. A better setup would be something like set this up in GitHub Actions or Circle CI. You can do that. It works. I've done it before. So let's run the test one more time. And what we would expect to see is a failure, right? Because there's a visual difference. Let Chrome do its thing, and boom, boom, boom. Back up to Applitools. It's running that there test across all the things. We'll just compulsively refresh until we get some results, right? Give me the answers. Unresolved. Oh crap, this is no bueno. What happened here? So while the others are going, interesting. So it's not necessarily failed, it's unresolved and it's orange, it's not red. What's going on here? So if we open this up, we can see that in our two snapshots, there's nothing highlighted here, but there is stuff highlighted here. So if I open the login page, that magenta color highlighting is showing, hey, it's pinpointing the icon was different, the sign-in button was different, and the remember me had shifted. So it's identifying 3 critical visual differences. Now it's up to us to decide were these good or bad. right? If this was a deliberate change and I wanted to say, yes, this is good, I could say thumbs up, and then this becomes the new baseline, and all future things are checked against this. But I don't like this. I think this is broken. I'm giving this a thumbs down. And when I do that, Applitools will do two things. It'll take you on to the next comparison that had a visual difference. But then it also runs a process in the background to identify any similar changes across other tests so that I won't have to go in and mark thumbs down on 10 different ones. It'll identify most of those 10 as being similar enough to say, yep, this is still bad. So your maintenance burden isn't as bad as you might think it is. So I come back in here, if I refresh. So yeah, it automatically marked a couple other tests for me. So I can come in here, I can mark the rest of them. Yeah, that's a thumbs down. It's doing it again. Yep, and that time it marked even more. Yeah, this one, thumbs down. Let's see who can win, who can do it faster. Thumbs down. This is all failing. Boom, boom. Okay. So we have marked our tests as failed. Boom, boom, boom. And now we'll save these results. And so if we were to rerun the test again with the failure, it would no longer be unresolved. Applitools would automatically mark that as a failed test. And if we were to run the original version again, that matches the baseline, Applitools would go back to passing, which is cool. We look in PractiTest here, refresh. We can see that the result was marked failed here. Basically, any non-passing result would be uploaded to PractiTest as a failure. So what you would do as part of your test execution, most likely in your test suite, you would have tests that do both traditional assertions as well as visual assertions. PractiTest would be your place to manage overall test result, like to say, hey, did we have any question marks? Did we have any failures? Do we have anything we need to investigate? Those would be marked as failures here. And then of any of those, if there were visual failures, you go into your Applitools dashboard to really look and see like, okay, what exactly failed visually that I need to dig into? Because like we saw here, there may be one test, but that might result in 10 different visual snapshots across different platforms. And even then that could be multiple visual snapshots per platform. So here, even though there was one test, but it ultimately fanned out to like 20 snapshots, right? So PractiTest would be tracking at a test level. Applitools is tracking at a snapshot, so to speak. So yeah. So yeah, I like things to be passing, so I'm going to mark it back as the original, and we'll run it one more time, and we should see everything goes back to being happy and green. Right. Okay. Boom, boom, boom. Boom. Okay, it's going to run Rudolph, and we'll see. Yep, the next batch is up. Come on, give me the green. Give me the green. I like the green. Green is good. Yep, there we go. We're passing again because it went back to the original, and therefore no visual changes detected. We're good to go. Ta-da, success. Cool, cool. Wait just another moment for it to finish the results, and then we can verify. PractiTest also got that nice green passing result. Come on, man. I said you were fat. There we go. 40 seconds this time. Not too bad. And over here, passed. We're green again. And if we look at our test set, again, haha, green. Woo! Fantastic. Slideshow. Oh, shoot. I forgot to show this slide. Yeah. So the demo I just showed, it's based on this GitHub project, Automation Panda / Visual Testing Revolution. You can capture this link, take a quick snap on your phone. This QR code will take you right to that GitHub repository. You can try this yourself. Get an Applitools account, get a PractiTest account. You'll just need to set up the environment variables. If you do want to use it with PractiTest, like you will need to set up a test instance, and then edit the code for your excuse me, your test instance ID, but it's all in there. So before I conclude this talk, there's one more thing real quick I want y'all to consider. Sorry, Marianne. And that is when a team should adopt visual testing. I can't tell you how many times folks have told me, Andy, that visual testing thing looks so cool and so helpful, but I don't think my team will ever get there. We're just getting started. We're new to automation. Automation is so hard. I don't think we'll ever be mature enough to adopt awesome tools like Applitools or even PractiTest. And when I hear these things, I'm just kind of smacking myself in the face, because these tools exist to make your job better. They're there to help you, to make things easier. I think teams should be doing visual testing and aside test case management from the start. I mean, consider this strategy. You start by automating a smoke test that navigates the different pages of your app and captures snapshots of each. The interaction code would be straightforward, like we saw. Snapshots are one-liners. This would provide immense value for relatively little automation work. It's the 80-20 rule, 80% of the value, 20% of the work. Once you do start to mature a little bit more, then when your team has more time and more expertise, you can expand your automation project with larger tests that use both traditional and visual assertions. Make things easy on yourself. You get a lot of value for a little bit of work sometimes. Test automation is hard no matter what tool or language you use. Sorry, it is. Just because it is software development. Teams struggle to automate tests in time and to keep them running. Visual testing simplifies implementation and execution while catching more problems. It offers the advantage of making functional testing easier. It's not a technique just for the bleeding edge. It's here today, and it's accessible to anyone doing test automation. I think it's a winning strategy. Has several advantages over functional testing, traditional functional testing, because visual testing is functional testing. Note that visual testing does not replace functional testing, supercharges it. With tools like Applitools, you can do visual testing in any major language or test framework. You can use any browser configuration or device platform. So if you want to give it a try, sign up for a free account, clone that example project, and get running. And add PractiTest in there too, because it works together. Yay. So take a picture of the slide. This is the picture time. You've got the 5 key points. You've got the links to the things. Yep, there you go. You got it. So thank you all for attending my talk today. Again, I'm Andy Knight. I'm Automation Panda. Catch me on Twitter at Automation Panda. Check out TAU and give visual testing and test case management a try.
Wow, Andrew, that was quite a webinar. So chock full of, yeah, more power to you. Chock full of a lot of stuff to think about. And wow, well, we do have quite a few questions.
Okay.
So let's see here. Do you see them, don't you? Okay.
Oh, I can pull them up. Shall we go top to bottom?
Yeah, some of these are comments that you asked questions, while you were speaking, and then people like answered. So some of them are not quite questions. If you remember, a few minutes in, we have Yulia who asked something about how does it do it. I'm not sure if Yulia, if you want to retype what you mean does what. We would gladly answer that. If it's not possible to compare images due to a different display types. So if you want to,
yes.
Know what this is in reference to, you can answer.
Sure, I'll try to answer this, Yulia. If you need more context, feel free to message again. So the way that the visual testing works is when whatever automation tool you're using, whether it's like Selenium WebDriver, whether it's Appium, whether or not it's just literally like you have like image files in a directory or PDFs in a directory, Applitools will come alongside whatever that tool is, and it will capture those snapshots in the instance of whenever you make that call. So it's like, okay, I've loaded my login page. Let me capture a snapshot of that. And it will capture all the stuff that makes it special. It takes that snapshot, it uploads it to the Applitools cloud, and it's in the Applitools cloud that the magic happens, right? It's going to take whatever information it has and render that on the target platforms. So if you want to render it on, 1200 by 1600 Chrome, or you want to render it on, Safari on an iPhone X or something, I don't know, right? Whatever you want. And so then from that rendering, that's when it turns the snapshot into like an image file. Like it'll get like a screenshot from that re-rendered snapshot. And then the visual AI algorithms will run on that and try to figure out like, okay, how does this compare to the previous one? And that magic I don't know a whole lot about. Like that's above me. There's some big brains in Applitools to figure that one out, right? And then that's when it will show the screenshot there. So when it comes to these snapshot comparisons, to keep things apples to apples, like we do say like, okay, you're going to have this particular web page rendered on this very specific browser configuration. And that's going to be the one it always compares. So if you're rendering on this browser configuration, you can have the same page rendered on a different one, like here's Chrome and here's Safari or something. But we're never going to compare Chrome to Safari. It's always going to be Chrome to Chrome, Safari to Safari. So that's how that works.
Okay, I hope that answered her. Okay, well, actually, Yulia had a lot of questions. So some of them are like mid-thought, so I'm trying to see what the beginning was. Is there a way to output results on a snapshot comparison to a text?
So So after the test runs, there are ways that you could like poop out in like a console log or something, like here's what the results were. In fact, there's one post-process job you can use with Applitools Runner to be like, here's all the results from all the tests, poop it out to a log. You could do other kinds of tie-ins with depending on what your test framework is and whatnot. It's possible.
Okay, a few more questions here. Do visual tests need to be handled differently than traditional tests in a test management system like PractiTest? I think I can even answer this, but no, not essentially no. But this is a PractiTest question. So, but you did mention it. I mean, PractiTest gets all the results, including visual test results, and compiles that and presents that and helps you manage that. So it's not really different because it applies for all. What languages and test frameworks does Applitools support?
Many. So basically, if any of the major languages or the major automation tools, like UI-based automation tools, Applitools will have an SDK for. So I showed Java. Oh my gosh. Good morning. I showed Java Selenium. Right. Selenium also comes with bindings.
Java is a pretty cool combination.
That is pretty awesome. We got to hashtag that one, right? But it's like Applitools has SDKs for all the Selenium bindings, JavaScript, C#, Python, Ruby, PHP. We support Cypress, Playwright, Puppeteer, Coded UI, all the Microsoft things, Test Cafe. There's even ones I'm not even thinking of. Please don't get offended if I'm not mentioning your favorite. Applitools, like I said, also is like mobile, like Appium, all that kind of stuff. Espresso, XUI test. And even apart from a test framework, like I said, if you just have like a directory of PNG files or PDF files, we have an images runner or SDK. I'm not sure what the official name of it, but basically it's like a command line tool. You point it at your directory and it just goes through there and it's like picks up all the images and treats them as snapshots, even though they're kind of frozen as screenshots, whatever, but you can still do it that way. So sky's the limit.
Can it be linked directly to Jira Issue Manager? If you're talking about PractiTest, then yes. We do have an integration on all of Jira's cloud and on-prem and whatever. So yes, and of course, if you ran something, visual testing with Applitools and it reported to PractiTest and there's a fail in issue, it can be reported as a Jira issue and back and forth and so on. So yes. Do visual assertions automatically wait for the page to be loaded before capturing a snapshot? That's interesting, the timing of it.
Great question. The answer is no. any sort of weighting or synchronization is going to be the responsibility of the script that is running it. So you would need to make sure that the page or the element or the region of the page is ready before you take that visual snapshot.
Okay.
So just something to note.
That it makes sense too. What would happen if there is a table on the screen, and once it has 5 items and then next time 20, what would that be a fail?
Oh, that is an excellent question. So something to note about the visual checkpoints that I didn't quite dive deep into is that there are different levels or ways in which you can manage those checks. So we did see the pixel to pixel versus the strict comparison, but we also have things like layout comparison and content comparison, because there are times where it's like what you really want to check is to make sure the layout is okay, and whatever data is in, let's say, the rows of your table doesn't matter. It would be pesky if it's like, yeah, the table's the same, but I went from 5 to 6 rows and now it's like blowing up and I'm getting these failures. That's noisy. We don't want that. So you could do like a layout comparison versus a content comparison where it ignores whatever is in those table rows. And with that kind of thing, you can say, okay, the table's still rendered correctly, garbage in, garbage out as far as the data in the rows. I'm going to still mark this as pass. And you can put that in your eyes check call as part of the massaging of the type of check that's done, so that within your script, it just knows this kind of visual check is honed to be this particular way.
Okay. Does Visual AI report the number of differences between snapshots? So not just is there or isn't there?
I don't believe so. Because it'll show you the image of like, here are 3 differences, but it won't give you a little pop out of the number 3, right? You as a human have to go in there and look.
Okay. Does it support testing motion pictures?
Ooh, that's a great question. I don't know the answer to that, to be honest. I think Applitools is working on something like that.
It sounds like it would be in the roadmap, having everything so video, interesting.
Yes.
So I guess we'll have to see. Okay, well, it's almost the top of the hour again. And I want to thank you very much. And if we didn't get to your specific question, you can always contact Andrew. Yeah, the email will also have his contact information, and the website. We will be sharing, as we always do, a recording for people who are here and want to listen again, or just find something specific and go back to it. And of course, people who aren't here but don't know that right now, they will be getting a recording as well. So thank you very much, Andrew. And I wish everyone, wherever you are, a good rest of the day, a good morning, good afternoon, good night, we like to say, wherever you may are, maybe. Thank you for joining us.
Thank you for having me. Thank you, everybody. Bye-bye.
Bye.